Hello friends, welcome to our channel. Let's look at problem 2948. Make lexicographically smallest array by swapping elements. So basically in this problem, we are given a array called nums, and also we are given a positive integer called limits. So in that operation, we can choose any two indices to swap the two numbers at those two indices, as long as the two numbers have a distance bounded above by a limit. So we want to return the lexicographically smallest array that can be obtained by performing the operations any number of times. So I know this is actually very easy to understand, but now let's try to understand this part. So here are three examples. Examples 3 are very special because for any two numbers in this array, so their distance is greater than 3. So the original order will be the order for the result, right? So that's what we want to return. And example 1 is also very easy to analyze, right? For example, and because 1 is already the smallest, so we can change 5 and 3 because these two have distance 2, so you can make 3 in front of 5. Similarly, you can change 9 and 8, right? Because 8 is smaller, so I put 8 in front. So this is the output. And the example 2 is very good because here it has two ones, right? And then the result is not what you might imagine, like 1, 1, something else, right? But it's 1, 6, 7, 18, and 1, 2, right? So we are going to use this example to demonstrate our main idea. So here you can also look at the constraint. So this first one determines the problem size. And the second one says that the numbers are in between 1 and this 10 to the power 9. And the limit is also in this bound. So with that said, let's look at our main idea. So here the main idea will be the following. We are going to chain the elements into groups. And then for each group, we can make the subsequence formed by the corresponding indices in sorted order. So I'm going to use example 2 to explain the procedure, and then we just need to code out this procedure. So basically the first step is to sort. You sort this to chain, right? So after sort, you will get 1, 1, 2, 6, 7, 18. So there's nothing to explain. So now we want to chain them together. So the condition to chain them together is that if the consecutive 2 actually has a distance is bounded by the limit, because we have already sorted the list, then the latter is greater than or equal to the former. Then we just need to consider the difference of the latter one minus the previous one. So if it were less than or equal to the limit, then we just add to the same group. For example, 1, 1, right, 2, you can add 2 here, but you cannot add 6 because 6 minus 2 is greater than 3. So we stop at 2, and then we start a new group, 6. Then we look at 7. 7 minus 6 is less than the limit, so we add 7 here. Then we look at 18, because 18 minus 7 is very large, right? So we couldn't add 18 to up to the list here. So we form a new group. Let's call it C2. Then we start a new one with 18, right? Because 18 is also the end, so the third group contains only 18. Then after we group the element into different sublists, so we can scan the original nums and assign the values. So we can initialize a list result, right? That has a length n. Then if you look at the first element, that is 1. 1 belongs to the first group, right? Then we are going to assign the index 0 with the smallest in group 1, that is 1, right? And then group 1, because we popped 1 from the left, so you get 1, 2. And then you have 6, 7, C2 and C3 remain. So when you look at the index 1, it's 7. 7 belongs to group 2. Then we assign index 1 the smallest for the group 2, so that is 6. So now you can look at the state of C1 and C2. When you do the assignment, you always assign the remaining smallest in each group. So for example, when you look at index 2, the number is 6. 6 is in group 2, right? Then assign the smallest current, that's 7, right? So you can update the group information. Then for I equals 3, so for I equals 3, so it's 18. 18 belongs to the last group. Then we assign result 3 to be the current smallest in group 3, that is 18, right? So now you look at the state. So C2 and C3 are empty. Then we have 2 remaining ones. So at index 4, you have 2. So then 2 belongs to the first group. Then I assign the current smallest, that is again 1. So then you have the state. C2 has only a 2 left, and the C2, C3 empty. Then for the last one, it's 1. It belongs to the first group. Then we get 2 sent here. Then C1, C2, C3 are empty. So that's the result, 1, 6, 7, 18. So overall, it has 3 steps. First, you sort and then break into groups. And then you give each group a name, right? And then you assign the corresponding positions according to group. It's like you have a number of rooms, then I assign different people to different rooms, but with order within that group, each group or each room. So with that said, I guess it's rather straightforward to code the solution out. And actually, I'm going to use, here I'm going to use, let's see, I want to use a queue actually. So here I'm going to use this collections deck, because I'm going to use pop left when I do the assignment. So this is actually very neat. So in other words, once you digest the logic, so you have the freedom or flexibility to design the code format. So first, I'm going to get the length of this nums. So that's routine. So now what we do, so because we also need to retrieve the original nums, so let me introduce another name, sorted nums, that is sorted nums. And then we can do the groups. So the groups. So let's, because we just need to for y in sorted nums. So then we are going to check if not groups. In other words, we haven't have an element in the group yet. So this is the one consideration. Or if it's not empty, then we are going to check or the current element minus the groups, the last is a list or deck, the last element, if it's greater than the limit. So in this case, it means that we need to initialize a new list, or more precisely, a deck we're using. Essentially, we're using the deck's queue behavior. So we're going to do groups, append, right? So you can append this one, and this is what we typically do. But here, what I'm going to do is I'm going to add a deck, because this way later I can use pop left. So this is the one. Otherwise, it means that the last element in the last group is within the distance limit, right? So then in this case, we want to do groups, the last group, then append the current element. So this way we form the groups. So let me add some annotations. Sort the numbers. So here, form groups. So you can actually print out these groups. Print groups. So you can see the format. So you can see the first one basically give you 1, 3, 5, and 8, 9. So 1, 3, 5, 8, 9. So now if you look at the second example, it's 1, 1, 2, 6, 7, and 18. It's the same here, right? So with that said, let's continue the coding. So now I'm going to delete this part. And then we are going to give a name to each group, right? So here I'm using C1, C2, C3. But here what I'm going to do is for all the elements in each group, I've just used the index. So basically I can use a dictionary, right? So basically it's going to give the element and the group name or index or group index, right? So here I'm going to do is for I group in enumerate groups. So I'm going to regard this I as the name of that group. Therefore, for element in that group, right? So you are going to assign the name of that. In other words, this dy equals I means that for this element, it belongs to group I, right? Or cluster I. That's it. So you can also print out this d. So because here corresponding to 1, 3, 5, this is the one group. So you have 1, 3, 5 belongs to cluster 0. And 8, 9 belongs to a group marked by 1. So you can also look at case 2, right? So we know 0 belongs to 1 belongs to group 0, 2 belongs to group 0, 6, 7 belongs to group 1, and 18 belongs to group 2. Same here, right? Corresponding to C1, C2, C3. So with that said, we are ready to do the last step. I'm going to delete this part. So the last step is to get the result. So I can assign some arbitrary number. Let me use none. Then I'm going to scan over the original list. So for I, Y in enumerate the original list. Then first I'm going to get the group. So the group ID. So it's D of Y, right? So giving me this Y, I want to call this D to get the group name. And then I'm going to assign the result to the current smallest number in that group. So this is very neat, right? I just need to get the group ID, right? Then this is the deck I can call pop left, right? Then that's it, right? So we just need to return the result. So here is assign. So that's actually the full coding for this problem. Now let me first do a check. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the generic cases very fast. So with that said, I guess that's about it. So now let me give you a quick summary. So here we do sort first. The purpose of sort is to change the elements into different groups, and then we give a name to each of the group, and then do the assignment. So in between, we used a data structure called deck. Essentially, we used its queue behavior. So specifically, we are using this pop left operation. So that's about it for the full video. Thank you for watching.